let's go first to this plot, the sequence duplication levels. And I'm very briefly going to show you here. So Galaxy uses an old version of FASTQC. If you use the most recent version of FASTQC, you see that it only contains one line, and the old version contains 2 lines. Yeah? But you see that the line in the recent version is exactly the same as the blue line here in the old version. So it shows the same information, it just shows less information. And you can see here that he's not happy with this plot. It's a red cross. And here on the slide, you can see the rules that FASTQC applies for calling a warning and for calling a failure for this plot. So, and the rules that FASTQC uses to call a warning or a failure in this plot are related to the number that you see here on top of the plot. So the percentage of reads that remain after you remove all the duplicate copies. So in this FASTQ file, 37% of the reads would remain after you remove the duplicate copies. The line that you see here shows the distribution of the duplicates. So how to interpret it? Along the x-axis, you have the duplication levels. So these reads occur only once in the FASTQ file. These reads occur more than 10,000 times in the FASTQ file. On the y-axis, you have the percentages. So in this FASTQ file, 30% of the reads occurs only once. Around 7% of the reads occurs twice, and so on. So this is an RNA-seq sample. So seeing high levels of duplicates is quite normal here. But he does call a failure, as you can see here, and that's just because the rule says that if the percentage of remaining reads after deduplication is below 50, he should call a failure. So for all RNA-seq libraries, FASTQC will call a failure, although it is quite normal in these libraries to have these high levels of duplication. So this percentage is of no concern. And the same is true here for the plot. So what you see here, reads that occur more than 10 times, more than 50 times, more than 100, more than 500 times, they are all reads that originate from these highly expressed genes. So it's normal that they are here. The only thing you really have to watch out for is here, the far right of the plot. When you do see a sharp peak here, so for the reads that occur more than 10,000 times in the FASTQ file, this peak often points to contamination. And this is not only true for the RNA-seq libraries, but also for DNA-seq libraries and for ChIP-seq libraries. So what percentages of duplicates are acceptable? Well, it really depends on the library that you work on. So DNA-seq libraries with randomly cut fragments, there you expect to see no duplicates at all. So you should have at least 90% of reads that remain after deduplication. In RNA-seq libraries, you expect to see duplicates because of the highly expressed genes. So here you expect to have at least 25% of reads remaining after deduplication. When you see percentages of remaining reads after deduplication below 10%, then you really have a problem. It's not that you have to throw away your data, you have to remove the duplicates, but it does mean that you're going to lose a lot of reads. Yeah? More than 90% of the reads will be removed from the FASTQ file. So the number of reads that you can use for analysis will be reduced by a factor 10. And this is, of course, not ideal. The reason for these high levels of duplication can be very diverse. You can have a small library, so a lot of PCR needs to be done to generate enough fragments to be able to detect the signals during sequencing. Remember the chip sample. You can have a library from a very small genome. Also here, you need to have enough fragments to be able to detect the signals during sequencing. So either you have to cut a lot of DNA or you have to do PCR, but either way, you are going to generate exactly the same fragments multiple times in your library. So for a chip sample or for a DNA-seq sample from a small genome, duplication is to be expected. However, if you see these low numbers for any other DNA-seq sample, you have to contact your sequence provider because this is not normal. In RNA-seq libraries, high levels of duplication are typically a sign of contamination with ribosomal RNA. The sequence provider should remove the ribosomal RNA from the total RNA when he makes the libraries, but I have seen cases where the removal was inefficient or not done at all. So ribosomal RNA is expressed in extreme high levels, so inevitably these sequences will come up as duplicates in your FASTQ file if they were present in the RNA-seq library. Here again, I would not throw away the data, I would still analyze it, but in this case, you will have to remove the duplicates from the FASTQ file. So although it is an RNA-seq library, it is contamination, it's not biological duplicates that you're interested in. So here, in that case, I would remove them. And you will lose a lot of reads because of that, which is of course a pity. So to interpret the plot here, you have to take into account the overall quality of the data. So if the quality plots, this one, and this one, show that the quality of the reads is low, this will have implications for the duplication levels. Because to find duplicates, FASTQC will look for reads with exactly the same sequence over the first 50 bases of the reads. And when the overall quality of the reads is low, there will be a lot of sequencing errors, so he will miss a lot of duplicates because of the sequencing errors. They will not be identical anymore, but there will be sequencing errors.